Welcome to the Kendrick Astro Instruments YouTube video demonstrating the function and functionality of the Kendrick Micro Firelight Controller. This is the smallest controller in the Kendrick line. It's very compact and lightweight, weighing only 1.6 ounces or 36 grams, excluding the power cord. It has two outputs, unlike many of our controllers which have 4 or more. It has a one-button interface to control on-off and programming. The controller is programmable in 10% increments from 10 to 100%. It has a low voltage cutoff with LED indication. It's RFI clean, which is a great feature for all you CCD imagers. It includes a lanyard to hang the controller. The lanyard is connected to either of these tabs, and then you can hang it from a knob or whatever from your mount or your telescope. We also include the Velcro so that you can stick it to a surface if you choose instead of using a lanyard. So who would this controller appeal to? Well, anyone requiring a compact, inexpensive controller with excellent features and functionality. You can install it on the upper tube assembly on a Dobsonian where weight can be an issue. It's a great controller for anyone who doesn't require more than 2 heaters. It's great for anyone using camera cozies or an imaging setup where you really only a need for 2 heaters. And it's a great backup controller should you have any problems with your main controller. The controller that I will be demonstrating has the LED lens removed. There's a lens here which diffuses the light from the LED on the circuit board. And the reason I have removed that lens is that the LED is quite dim in daylight. It's bright enough for nighttime use, but for demonstration purposes in this video I will have removed it so that you can actually see the video or the LED on the video. So I will now bring that modified controller into the field of view here. And here it is here. You can see I have removed the lens here. It's just an open hole on this, exposing the LED on the circuit board. Connected to this controller I have this LED array, and I'm using this LED array to demonstrate the power functionality on this controller. And when the power is on, the LED will turn on. And it shows it in direct correspondence to the flash on the LED. So, on-off. To turn this controller on, you press the button and release. In this instance, that green LED will flash 5 times. That indicates a 50% duty cycle has been programmed into this controller. And you can now see that the LED is flashing in direct correspondence to the LED on the circuit board. To turn it off, you just press it and release. The LED pulses blue and turns off. It's that simple. Now I will demonstrate how to program this controller. To program, the controller must be booted up. So you have to turn this controller on, you let it go through its initiation process here, and when it is finished you can then enter the programming mode. So when it is now flashing green like that, it is safe to enter, or possible to enter, programming mode. So to enter programming mode, you press and hold the button and you hold it for 3 seconds. You can see that that light will pulse blue 3 times. And now it will flash. That's 10, 20, 30, 40, 50, 60, 70%. I will release it. It will now flash green 7 times to confirm that I've programmed in 70%. And then it will flash red and the LED comes on. So that is programming. And when you do program this, it always starts at the base level, 10%, and you work your way up. Let's assume you want to program 100%. We'll press this in, the LED will pulse blue 3, maybe 4 times, and it will flash 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it goes solid like that, that means 100% setting. Release it. It will now flash green 10 times to indicate 100% setting. And there you go. And even at 100% there is a slight pulse there, but for all intents and purposes that's 100%. I'm going to set this back to 50%. So I'm going to press and hold that button. 1, 2, 3 seconds, 10%, 20%, 30%, 40%, 50%, release. Confirm it. 10, 20, 30, 40, 50, into power cycling, on. And there you go. That's essentially the functionality on this controller. There's not much more to it than that. I will demonstrate low voltage cutoff for you. Low voltage cutoff, again, is a function to protect your lead acid battery from being too deeply discharged. Lead acid batteries do not like or take well to being discharged below 11.5 volts. So we have that built-in functionality in here. When you get down to 12 volts, the controller is still functioning, but the LED will change from red to orange. And when you get down to 11.5 volts, the LED will pulse green every 6 seconds, but the controller is off. So if you're ever at your telescope and you see your controller is pulsing green once every 6 seconds, it's because you have gone into low voltage cutoff. And I will demonstrate this here. I'm going to lower the voltage down here on my power supply until we get this. Now you can see that has changed. It's 11.9 volts, and we're now got a sort of an orange flash going on there. I'll now lower this below 11.5, and now it's essentially gone off. And I'm not sure you can see this, but there is a little green flash there every 6 seconds. But there is, you can see the LED array is no longer flashing, and it is cut off. So that's the end of this demonstration for the microcontroller. I thank you for watching, and I hope it was helpful to you. Have a great day.